Okay, guys, today we're going to talk about basic squares and square roots. So we'll start with doing a square of a number. So for instance, we have 3 squared. When we have an exponent like this, we always have to remember there's a base and an exponent. The base is the large number. Okay, in this case, the base is 3, and the exponent would be 2. The exponent's a little number on top, so the exponent is 2. And what you would do is you would multiply the base. So it's just like all about the base, right? So we're only multiplying the base, and we're multiplying it as many times as what's on the exponent. So the exponent tells me how many times to multiply it. So in this case, I'm multiplying 3 2 times, and I would get 9. So you're only multiplying by what the base is, okay? You never multiply the base times the exponent. So let's take another look, and we'll put another one here. Let's say we have 4 to the third power. In that case, the base is 4, the exponent is 3. That means I'm multiplying the base, right? It's all about the base. I'm multiplying the base 3 times. So it would be 4 times 4 times 4. So that would be 16 times 4, which equals 64. And that's how you would do that. Okay, that's working with exponents. So what we're going to do is we're going to look at how we would do square numbers, so raised to the second power, and we're going to look at specific instances that confuse kids sometimes. So for instance, we have 2/3, and we have 2/3 squared. And you'll notice the square is outside the parentheses. And when the square is outside the parentheses, that means everything in the parentheses is the base. So the base here is 2/3. Okay, so we're multiplying 2/3 times 2/3, right? Notice on the exponent is 2, so that tells us how many times we multiply it. So 1, 2, and then we'll just multiply like we would multiply normal fractions across the top and across the bottom. So 2/3 in parentheses squared is 4/9. Now I want to contrast that if I have 2/3 and it looks like this, and there's no parentheses, you have to pay attention to the fact that the exponent is only on the number that it's with. If the whole fraction isn't in parentheses, then that's not the base. The base in this case is only the 2, okay, because that's where the exponent is. It's on the 2, and there's no parentheses encompassing that 3. So I would multiply the 2 2 times, and then the 3 stays on the bottom, and the answer for this one would be 4/9. So that's how you would do a fraction. Now, we also have to consider, sorry about that, we also have to consider what would happen with negatives, okay? So let's say we have -5 squared. And when we have -5 squared, I want you to be paying attention. Again, the base is -5. It's in the parentheses, so the whole thing is the base. So that's -5, and we're multiplying it 2 times. So it would be -5 times -5, which would be a positive 25. Alternatively, you might have something that looks like this, -5 squared. Pay attention, there's no parentheses, which means the exponent is only on the 5. So the base here is 5 and not -5. So it would look like this. We have a negative sign, and then we're multiplying 5 2 times. So we would get -25. Okay? So that's what when we're talking about squares, those are the ones that can catch us off guard. Okay? Now I want to talk about what a square root is compared to square. All right? Square root is the inverse operation or the opposite. So you might have, let's say we have 4 squared. All right? Again, the base is 4. That means 4 times 4, which would be 16. That's squaring. Okay? Now let's talk about a square root. A square root looks like this. And I might say the square root of 16. That means I want to know what number times itself, all right? It's what number times itself is going to give me 16? And the answer to that would be 4. Another example might be the square root of 25. What number times itself gives me 25? And that would be 5 times 5 gives me 25. So the answer to that would be 5. The inverse or opposite operations. So if you notice on this side, 4 squared equals 16, and the square root of 16 equals 4. So for instance, let me make that a different color. 10 squared equals 100, and the square root of 100 equals 10. So this means 10 times 10, and this one here means what number times itself gives me 100. Okay, and so they're opposite operations. Okay, so let's talk about finding the square root of something if it's in fraction form. All right, so we might have the square root of 4 over 25. There's a couple options here. You could divide 4 divided by 25 and see if that gives you something good to work with. It does not, because it comes out to a decimal answer, and we're looking for a perfect square like 100 or 25 or 16, what numbers that we know whole numbers multiply evenly into. So what I could do, though, I could take the square root of 4 over the square root of 25, and I could separate it that way. And then I'm just going to do, what is the square root of 4? What number multiplied by itself gives me 4? And that's 2, right? 2 times 2 gives me 4. And what number times itself gives me 25? That's 5. And so the answer would be 2/5. And I just want to prove that down here. 2/5 times 2/5, right? If I do out that math, I'm going to get 4 over 25. Okay? So you can see if I want to find what number multiplied by itself gives me 4 over 25, that would be 2/5. 2/5 times 2/5 gives me 4 over 25. And that's what we're trying to do when we find square root. So let's look at another example. Let's say we have something like 4 over 10. Okay? So we have 4 over 10. Now, simplifying that isn't going to help anything. It doesn't give me a good perfect square like 4, 9, 16, 25, something that I know whole numbers are the answer to that square root. But what I could do is I could do the square root of 4 over the square root of 10. And as you get older, there's more in-depth things to do with this. So we're kind of at the general basic stage. So we know the square root of 4 is 2, right? 2 times 2 equals 4. And 10 doesn't have a perfect square answer. There's no whole number times itself gives me 10. So I'm going to just leave it like this, which is okay for now. As you get older, you're going to want to do some work with that to make it more what I would call math proper. Okay, so you can do that. Now, another example would be something like this, where we might have a fraction that looks like this: 20 divided by 5. Okay, and if you rewrite it like this doesn't help at all, because we don't know the square root of 20 and we don't know the square root of 5. So that's not helpful. However, we could do the math here, and we could do 20 divided by 5, which we know 20 divided by 5 is 4, and we do know the square root of 4, which is 2. And we can do it that way. Okay, and I'm just going to show you one last thing with square roots. Sometimes you may have a number on the outside. Let's say we have the square root of 25, and we have a negative sign on the outside. A negative sign on the outside doesn't change anything. I want you to be paying attention to inside the square root of 25 is 5. And then there's a negative on the outside, which makes this answer -5. Okay. So let's do a couple operations with squares and square roots. And I'm just going to write, let's say, the square root of 25. I'm going to square that -4. So let's say we have an operation like this. We're going to follow order of operations, which is PEMDAS, right? PEMDAS. which means parentheses, exponents, which includes square roots, multiplication or division, whichever comes first, and then addition or subtraction, whichever comes first. So here I'm going to go to the parentheses and I'm going to take the square root of 25, which is 5. And then I still have it, the squared, and so it looks like this. And then I would do the exponent, 5 squared, which is 25 minus 4, and 25 minus 4 is 21. Now, you can do it that way, but I want to point out the fact that squaring something and the square root are opposite operations, and so they cancel each other out. So this squared cancels out the square root sign, and you can just see that it's going to be 25 minus 4 without doing all the work. Okay, let's do one more problem here. Let's take a look. Let's say it looks something like this: 3, the square root of 16 minus 4. Okay, in this problem, there's no parentheses. There is exponents or square roots, which is right here. All right, so we want to do that. So the square root of 16 is 4. And then the math that's being done, be paying attention, between this 3 and the square root sign is multiplication. That's why there's no operation sign there. So now it looks like this: 3 times 4 minus 4. And next I would do multiplication. I would do 12 minus 4, and the answer would be 8. Okay, so that's how we can work with square roots and squares and how they look and what it actually means.